This video is going to cover series and parallel circuits. So in this top diagram we have the series circuit, and you can see here's the power source, the battery, or it could be an AC outlet, but then we have light bulbs, okay, and each one of those is one after the other, you know, like if you're standing in a line at the grocery store, one after the other. And so this is called a series, where you just have one after the other. The disadvantage is that if I say had a switch in here and I turned it off here, then it would turn off everything down. It would cut the flow of electricity. And then we had down here is a parallel. Again, here's the battery, and it could be the AC outlet too. But now everything is side by side with the battery, and we call this a parallel arrangement. So now if I had a switch, say right here, and I turned off this light, these other lights would still stay on. And so I say here, this is how your house is wired. So turning off one light will not affect the others. So again, series, one right after the other, parallel, side by side. And you may have noticed, one place that you may have noticed this is like if some of your electronic devices, you may see like I say D batteries, you know, there's like A, AA batteries and AAA batteries and C and D. And here I say these are D batteries, which we know are all supposed to be around 1.5 volts, okay? And so if we put them in series, one after the other, the voltages add. And so the net voltage measured from here to here, again, always voltages across things, then it would be 3. So this would be 6 volts. So if you had a motor in your electronic device and it needed 6 volts to run, then you could put the D batteries in series. Okay, this is the series one. And the voltages add. You may have also noticed they can be side by side, and this would be the parallel arrangement. In this situation, the voltage is across all of these batteries in parallel is still 1.5 volts, okay? But the capacity of the batteries now adds, okay? And if you look online, and sometimes it's printed on the batteries and sometimes it's not, it'll have the capacity for the battery, and it's usually in milliamp hours, okay? So I looked this up online. It says 1 D battery has a capacity of 15,000 milliamp hours. So what that means, it can provide 15,000 milliamps for 1 hour before it is depleted. Okay, then it's no good and you have to throw it away. Or, I mean, you could also say it could provide, say, 7,500 milliamps for 2 hours. That's still the same capacity. If you took this times this, that would become 15,000 milliamp hours. Or, I mean, or you could divide it by 5, so that would be 3,000 milliamp hours for 5 hours, okay? Timesing these two together, you still get to 15,000 milliamp hours. And so if you had like a device and it lasted like a month on one battery, it's not using the full 15,000 milliamp in 1 hour. It's maybe only using a fraction of it a day. But like I said, back here into the parallel arrangement, the capacities add. So if each one of these is 15,000 milliamp hours, now the total would be 60,000 milliamp hours. So if you had some device that had a large drain and needed a lot of current, then you might see it in a parallel arrangement like this. Whereas if you needed something with a larger voltage than 1 D battery, then you would see it in a series arrangement. Let's see, this is going to talk about switches, and there's two types of switches that they talk about in the merit badge. Single pole double throw. And so right here is an example of a single pole double throw switch. And basically you have your current coming in, and depending on the switch position, it can go to do two different places. It can go to this output or this output. So output 1 or output 2. And so here I have, you have a 9-volt battery. We have a single pole double throw switch here. And if it's in this position, say position 1, then the green LED will turn on. And if we're in position number 2, then the red LED would turn on. And so you can see it has 3 terminals. So this is the input, and this is output 1, and this is output 2. And then the other type is a single pole, single throw switch. So it's just basically on or off. So here again, we have a 9-volt battery, the single pole, single throw switch. If it's off, nothing happens. If it's on, then the LED right here will turn on. And so that's your typical light switch. And one of the projects that you can do for the merit badge is to make sort of an electric buzzer. I said bell here, but this is buzzer or bell. And the things that you'll need is a power source, again, a battery, a bell that you make. So we'll call this the buzzer, I think is what they called it. Some connecting wires and a switch. And so here's the power source, the battery. Then this area here is the buzzer, and this is the switch. And so what they have you do is you wrap some wire around a screw, and you make a little electromagnet. And so when you turn the switch on, the electromagnet turns on and say this is now a north and a south pole electromagnet, and the metal at the top bends down, and it breaks this connection right here where I'm drawing the little green arrow. And then once that happens, the electromagnet turns off and the piece of metal goes back up. But then that completes the circuit, and then the electromagnet comes on, and so it just goes back and forth, back and forth, back and forth really quickly, making a buzzing noise.